Hi all, myself Deepthi. Now I'm going to give a presentation regarding one of the software security weaknesses, buffer overflow topic. These are the contents which will be discussed in the further slides. Generally, a vulnerability is a weakness that can be exploited by an attacker. Thus, a weakness is an error, typically in the software code, that might lead to a vulnerability. Most of the weaknesses emerge after the release of the software to the public and millions of people begin using it. So coming to the buffer overflow, generally, buffers are memory storage areas that keep data briefly as it is transported from one location to another. A buffer overflow occurs when a program or process attempts to write more data to a fixed length block of memory or a buffer than the buffer is allocated to hold. Buffer overflows can affect all types of software. That sort of overflow can be avoided if the program includes sufficient bounds checking to flag or discard the data when too much is sent to a memory buffer. The most feasible and easiest way to detect buffer overflow vulnerabilities is to use programming languages that do not allow them to be used. So coming to buffer overflow attack. Buffer overflow attack takes place when an attacker manipulates the coding error to carry out the malicious actions and compromise the affected systems. A buffer overflow attack typically involves violating programming languages and overwriting the bounds of the buffers they exist on. It typically occurs in code when the code is so complex that programmers are not able to predict its behavior accurately, or the code dependent on data properties that are enforced beyond its immediate scope. Coming to the types of buffer overflow attack, one of the most common form of buffer overflow attack is stack-based buffer overflows. The stack-based approach occurs when an attacker sends data containing malicious code to an application which stores the data in a stack buffer. So this writes the data on the stack, including a return pointer which hands the control of transfers to the attacker. Coming to heap-based buffer overflows, it is more difficult to carry out than the stack-based approach. It involves the attack flooding a program's memory space beyond the memory it uses for the runtime operations. And the another type of buffer overflow is that format string attack. A format string exploit takes place when an application processes inputted data as a command or does not validate the input data efficiently. This enables the attacker to execute the code, read the data in the stack, or cause the faults in the application. And then coming to how to identify and detect the buffer overflow attacks. Usually weaknesses may be caused due to some misuse of security tactics during the architecture and design phase. So in order to identify or detect the buffer overflow vulnerabilities in source code, the general steps to be followed are like manipulation of external input and buffers should be investigated, and it also very crucial to understand how they work, and determining which functions are vulnerable to this flaw and can serve as early warning indicators of its presence. So coming to this example, when we're looking at this code, it is clear that no bounds checking is performed here. So if the user enters maybe, then the program will like stop working rather than asking the user for a valid answer and reprompting this question. The user's answer is simply written into the buffer regardless of its length. So in this example, we can see that user underscore answer is the only variable declared here. The next values on the stack would be the return address value or the location in memory to which the program will return after running the ask question function. This means that if the user enters 4 bytes of data followed by a valid address in memory, the program's return address will be modified. So this allows the user to force the program to exit the function at a different point in the code than originally intended, which leads to a dangerous ways. So anywhere using one of the functions like string copy, string cat, and printf getters, there is likely to be a more buffer overflow vulnerability. Next, coming to the risks of a buffer overflow attack. Remote code execution is too challenging with a buffer overflow attack. Hackers can cause havoc by using buffer overflows to simply cause application crashes and the denial of service condition. Hackers would use a buffer overflow attack to achieve goals like service disruption. It is relatively easy to use a buffer overflow vulnerability to cause application to crash, bringing down the services. So coming to data loss, buffer overflow attacks can be used to steal the data by manipulating the application behavior. The attackers can redirect the outputs and illegally capture the data flows. Coming to unauthorized access, an attacker can use a buffer overflow vulnerability to gain the unauthorized access to the computing infrastructure, which could open the opportunity to an endless array of compromises to the attackers. So, coming to code execution, through a buffer overflow attack, an attacker can use your systems to execute code that the attacker wrote for the attack criminal gain. So, coming to the mitigation techniques, the mitigate techniques and methods are mainly depends upon the type of threats. These are the some of the mitigation techniques. Coming to data execution prevention, when exploiting the buffer overflows, attackers often place malicious code in places like stack and heap and achieve unauthorized execution in the context of the target application. Because of this, a new buffer overflow mitigation technique called data execution prevention is introduced here. Data execution prevention can be enabled at both hardware level and software level. This method prevents an attack from being able to run code in non-executable regions by flagging the areas of memory as executable or non-executable. Coming to address space layout randomization, usually the purpose of address space randomization is to prevent an attack from reliably reaching the target memory address. ASLR is one of the best mitigation techniques when compared to others. It is a memory protection measure for operating system that secures the buffer overflow attacks by choosing where framework executable records are put away in the memory. ASLR random memory addresses tend to imply that the malicious actor no longer realizes which addresses the necessary code. So coming to writing secure code, which is one of the best way to prevent the buffer overflow vulnerabilities. When the programs are written in languages that are susceptible to buffer overflow vulnerabilities, developers must be aware of risky functions and avoid using them whenever possible. For example, avoid using functions such as getters and use ifgetters instead, which allows the developer to specify how much buffer is expected. Source code audit, which is the go-to technique to ultimately ensure that there are no unsafe functions or vulnerabilities present that can lead to a buffer overflow attack. Structured exception handler override protection, which helps to stop malicious code from attacking the structured exception handling, which is a built-in system for managing hardware and software exceptions. It thus prevents an attacker from being able to use of the SEH function override explosion technique. Coming to compiler warnings, when developing a new software with vulnerable functions, compilers often provide warnings and recommend the use of secure alternatives of the functions used. Developers can quickly make use of changes during the development phase. Coming to training and awareness, which is one of considered as the most convenient and comfortable form of security, which is also least expensive and most effective. And patch management, application or system is not perfect from the security perspective. Any software is not perfect from the security perspective. Release updates and security patches which add more security and provide more functionality. Coming to example code, usually an attacker injects malicious code into the memory that has been corrected by the overflow. In some cases, the attacker simply takes advantage of the overflow and its corruption of the adjacent memory. Here, for example, considering this program, which requests a user password in order to grant the user access to the system. In this code, we can see that the correct password grants the user root privileges. If the password is incorrect, the program will not grant the user privileges. However, here there is a possibility of buffer overflow in this program because the getters function does not check the array bounds. Here is an example of what an attacker can do with a coding error. In this example, we can see that the programmer program gives the user root privileges, even though the user entered an incorrect password here. In this case, the attacker supplied an input with a length greater than the buffer can hold, creating buffer overflow attack, which overrode the memory of integer pass. So therefore, despite the incorrect password, the value of pass become non-zero and the attacker receives root privileges. So in order to prevent this type of attack, developers need to avoid standard library functions that are not bounds checked, such as getter, scanf, and strcpy. Although these days many of the developers are using the advanced programming languages, which use built-in safety mechanisms that minimize the likelihood of buffer overflow. Also, regular testing need to be done in detecting and fixing the buffer overflow attacks. Coming to the real vulnerability of buffer overflow attack, a vulnerability which was classified as critical was found in University of Washington IMAP server. University of Washington IMAP server is a popular free IMAP service for Linux and Unix systems. Remote exploitation of a buffer overflow vulnerability in the University of Washington's IMAP server allows the attackers to execute the arbitrary code. The vulnerability specifically exists due to insufficient bounds checking on user supplied values. The function mail underscore valid underscore net underscore pass underscore work, which we can see in that in is responsible for obtaining and validating the specified mailbox name from user supplied data. Here we can see in line 20 there is a search for a double quotation mark within the string being passed. So if it is found, the loop in line 22 will copy until a second double quotation mark is found. Clearly, if a string is entered that only has one such character, the loop will keep copying, overflowing the stack buffer and resulting in an arbitrary code execution. The main impact of a successful exploit in IMP server is that an authorized user can execute arbitrary code, including gaining shell access on the server. The code is executed with the authorized user's user ID. However, the impact of this vulnerability is slightly reduced due to the requirement of valid credentials. IMAP servers commonly are used for free webmail systems and other services which may give untrusted users with valid credentials. It restricted the untrusted users from the IMAP service until the vendor releases a patch. Finally, the vendor has fixed the issue by applying the patch to the source client library mail.c file. So by adding the state a condition if c not equals to which will return nil, so the infinite loop doesn't occur. The loop ends here. This is how the fix has been made to overcome the buffer overflow issue. This fix is in University of Washington release IMAP 2004 G version. It is recommended that the users need to be upgraded to that version. Coming to the other real-time examples, SQL Slammer, which is an 2003 computer worm, caused a denial of service on some internet hosts and dramatically slowed down the general internet traffic. Even the popular chat app WhatsApp also suffered from the buffer overflow attack, which is filed as CVE 2019-3568. The buffer overflow vulnerability was found in Adobe Flash Player, and this vulnerability was due to an error in the Adobe Flash layer while parsing a specially crafted file. Coming to the conclusion, buffer overflows are a serious issue as execution of the injected code can allow hackers to compromise the system. Linux and Microsoft have also taken measures within their operating systems to combat these buffer overflows, but ultimately it is on the user and the developer. Many developers have begun coding in compilers as a prevention method. So by following the secure code practices right from the beginning phase of the software, using memory safe programming languages and proper validation of the input, also software testing and maintaining the quality assurance is also important to mitigate the future risk. Also the code auditing is the important thing to ensure the quality of the code. These are the references considered. Thank you.